Thank you very much for the kind introduction. And thank you very much for letting me coming here to Sydney and this extremely interesting conference. I'm really excited about all the presentations that I've heard the last couple of days. And I hope that I can give you some ideas of what's happening also in Sweden. So this presentation will not only cover my own institute, it will also cover the work of the Swerea group. It's a group of institutes working with different kind of materials together with the industry. We have 5 institutes working with metals, plastics, composites, electronics, textiles, and so on. From foundries, steel plants, to car manufacturing plants, and also a lot of SMEs and other companies. We are located in different parts of Sweden. I come from the very north, 150 kilometers south of the Arctic Circle, but we have also some subsidiaries and our sister institutes are located all over Sweden. And we have some subsidiaries in France as well, corrosion institutes. So we are a Swedish industrial institute working for the industry, but also a lot with collaborative research. And of course, recycling is an important issue. First, I will give you 5 examples of how we work on recycling, but I will start with giving a short introduction of the situation of Sweden. Sweden have quite a lot of resources. We have energy resources. We have a lot of renewable energy like hydropower, some wind power, nuclear that is not renewable. We use organic waste to some extent, making biogas that starting to be becoming more and more common to be used for buses in local communities. We have waste incinerators that produces electricity and also district heating. To that extent that we also have to import a lot of waste into Sweden. We have a lot of material, especially iron ore, non-ferrous like copper, zinc, lead, gold. We have a lot of forests, and we have a lot of good quality water, drinking water. So we are quite fortunate. It's a relatively large country for Europe, not compared to Australia, of course. But we have a small population. But still, recycling is an important issue in Sweden to preserve the nature that we have. My first example is from the steel industry, of course. This is a tool that we have been using the last decade with a large success. It's a system analysis tool to make a holistic perspective for material efficiency improvements. A steel plant is a complex factory, actually. You put a lot of raw material into it, and it goes coupled streams within the steel plant. And then you have some CO2 that comes out of it, emissions, steel, and material for landfill. And of course, some material can be sold as byproducts as well. So this is one example of a study that we have done with one material that is somewhat troublesome, the fine sludge from the BOF steelmaking shop. It contains quite a lot of zinc. And we made a study, 2 cases with 50% recycling of this fine sludge via sludge pelletizing. So this is just a computer analysis. 50% or 100% recycling. And look what will happen with the whole system. And these are some of the results. Don't go into detail, but you see that if you start to recycle more of the sludge, it will affect the whole system because it's a coupled system. So a lot of the material streams are going back and forth. And after a while, the amount of blast furnace sludge will increase, and also the blast furnace dust. And then we have to use more briquettes. It also affects the charge material balance, and also the landfill. So by using this system tool, we concluded that we can actually recycle a lot of this BOF sludge. And the result would be that the zinc output from the blast furnace sludge will increase from 0.5 to 0.7%. But we will also gain a reduction of the landfill, need for landfill, about 40,000 tons per year. We would get slightly higher, slightly difference in hot metal composition. We would reduce the need of iron ore pellets and limestone for the system. So this is one example of how to use this tool. My next example is from a cross-sectorial solution. Cables that is used. We have, in a collaborative research program, come up with a solution how to recycle cables, not only the metal contents. The metal content is not very difficult, actually, but also the plastic part, and to produce new details of recycled PVC, different kinds. This is another example using recycled glass fibers, and we show that it's possible to make new composites with good properties with recycled glass fibers. Carbon fiber weave that is used in the composite industry, for instance, in the aeroplane industry. Oh, sorry. That is usually gone for burning, but it can be a very, very good quality material for making plastic details with very good strength. And also recycled textiles can be used to reinforce, it goes by itself, reinforce plastic composites. We have also shown that it's possible to recycle textile fibers and make new yarn. Crazy. And by mixing cotton and synthetic fibers, it's possible to make new yarn out of this. But of course, it is not, everything is not possible to recycle. There are cases where recycling might be a problem. For instance, the chair that you are sitting on right now contains flame retardants. That means that it might be a problem to recycle this material. And this might also be a question of chemical components that might hinder recycling. And another job that we are just recently got, what is a commission or a mission from our Swedish EPA to develop a platform, knowledge platform, for the governmental commission of textiles. How current collection system are affected by certain hazardous substances, contents, toxic, and so on in textile material to be recycled, and so on. So we can also work together with the governments how to make better systems, and also what kind of textile to be commissioned. But you can also use metallurgical solutions for taking care. So basically, a metallurgical process uses raw material, and you will get 4 fractions out of it. You will get a dust fraction, an off-gas fraction, slag fraction, and a metal fraction, depending on how you control it, the temperature, and so on. And this can be utilized in different ways. And I will show you 2 examples, or at least one quite newly example. Alkaline batteries. Alkaline batteries consist of steel shell, steel pin, and a mass of manganese oxide, zinc oxide. That is the electrolytes. And the steel shell, steel pin, that can easily be recycled. But the rest of the goods is normally going to landfill. But we show that it's possible to use metallurgical reactors to not only recover the metal and the plastic, but also the zinc content and the manganese content out of it. So we get a clean manganese and zinc product, 0 waste. And we think that it's the most efficient option for battery processing. And nowadays, alkaline batteries should at least not contain any mercury. But we have also thought of that it might occur. So another example when you can use metallurgical reactors is when you are processing dangerous chemicals, or PCB. We have shown that we can use metallurgical reactors to destruct PCB and dangerous chemicals. And then you can actually divide it metallurgically into its basic components, that is carbon, hydrogen, oxygen, and so on. And so metallurgical reactors is very effective. My last example is another project, collaborative project within our Swerea group. Together with universities and a lot of companies and some trading companies in recycling business, we have started to make a trading platform. We call it From Waste to Gold. And the idea is to make a brokerage platform for waste and services. So different materials, metals, textiles, powder, coatings, and so on, how to handle it, selling and buying. And the vision is this: Wiki Recycle. A homepage how to buy and sell secondary industrial materials, and working for higher value by moving up the waste hierarchy, and more easy transaction for sellers, and competence and just-in-time delivery for buyers. We will see how this goes. Normally, it is my experience is that you are failing on practical things, like how to package the material, how to transport it from A to B. But I think this consortium, they have also experienced how to deal with these things. Finally, I would like to say something about what's going on European scale. You probably have heard about the big research program, Horizon 2020, and within that we have a part that is called SPIRE, dedicated to innovation and in resource and energy efficiency in process industry. And of course, that is a lot of money, research money. It's great opportunities, but it's like a lottery. You work 2 months of hard work making projects, and then you cross your fingers and wish, and if you're lucky, you get funded. Another initiative is the Raw Material Kick. It's a Knowledge Innovation Center granted in January this year, so it's just recently started. And it will also work with primary raw material, secondary raw material, that is recycling mainly, and substitution. And recycling is a very important part of this. And it's not a research program, it's mainly how to make more business and entrepreneurship and education out of research projects. So still it's connected to research. Finally, on a national basis, after my speech here, I will grab my things and go back to Sweden, because tomorrow we will have a kick-off meeting of a new national innovation program called Resource, for sustainable resource and waste handling. So in this program, we work with industry, society, and academia, focusing on material, recycling, and energy recovery. And the objective is to decrease waste amounts and decrease dependency on primary material resources and decrease the use of fossil fuels. So within a few years, we will see what the outcome, but it's a rather big program actually, so it will be quite interesting. Like 10, 15, or 20 million euros, something like that. So, in conclusions, there is a strong focus on recycling in Sweden and also in Europe. And some of the objectives is to decrease the CO2 emissions and decrease the dependency of fossil fuels, but also decrease the dependency of virgin raw materials. Increasing rates of recycling is inevitable and necessary, but recycling, of course, will not completely replace the use of virgin raw materials, but we should be very aware and we should be careful with our virgin raw materials. And finally, we have also seen that competition of waste can also already be seen. And I have heard that during the last couple of days that you can also see it to some extent starting here in Australia. But this competition will increase. Waste is not a waste, it's a raw material for somebody else. So, finally, I would like to invite you to our Metallurgical conference next year in June. I make some advertisement here. So, thank you very much.